Good afternoon, everybody. Welcome to another session in mathematics. I would like to say a special welcome to Bridgetown. As you have New Orleans, we have the Rocklands with the principal, Mrs. Strauss, and let's not forget all the wonderful learners in the Northern Cape with a special hello to Mrs. Abrams as well there in the Northern Cape. Welcome to all of you. I hope there are more viewers and more visitors that is connected. If so, send us a special message. Okay, learners, in the previous session, you worked with the inverse graphs of number 1, the line, and number 2, the parabola. Today, we're going to look at how we can solve the inverse graph of the exponential graph. It's quite a mouthful. It's definitely always a popular exam question. So I hope you have your paper ready, your calculator, and obviously your pen, and I need you to assist me working with through some of the examples. Right? There are times when I would like you to give me some answers, send it to me so that we can work through these sums together. Well, enjoy the session. Let's have a look at a PowerPoint presentation. We've covered up till now, like I've mentioned, inverse functions. Number 1, the inverse function of the linear function, as we know it as y equals ax plus q, or also you will know it as y equals mx plus c. That is the line graph. Secondly, you've worked with the inverse of a quadratic function. That is what we call the parabola, which is the equation y equals ax squared. Today, we are going to work with the inverse of the exponential function. And the standard form that we're looking at there is y equals ax to the power of x. Right? Y equals a to the power of x. Now these are the 3 inverse functions that you need to know for your exams. Just a few key points I would like to give you. Right? Just a few key points. Number 1. If fx is given as 2x, that means the function. Then we will write the inverse as f to the power of minus 1. In other words, learners, if you see something that says f to the power minus 1, g to the power minus 1, that means the inverse of the graph. Secondly, to write the inverse graph, normally what you need to do is swap the x and the y, and after that you write it into standard form. So once you swap the x and the y, you will have to write it in the form y equals, and you have to complete the equation. Thirdly, you need to know that the inverse function is a reflection across the line y equals x. Right? All inverse functions, it's a reflection across the line y equals x. And then lastly, the coordinates x and y on a given function will be swapped in order to sketch the inverse. Right? The coordinates x and y on the given function, you have to swap that, and that will give you the coordinates of the inverse function. Now, what do you need to know before we get into the inverse? You need to know that y equals 2x is an example of an exponential graph. Right? You need to know that. Right? You need to know how to sketch it. You need to know some characteristics, and therefore, from there, we will sketch the inverse graph. Now, looking at that, we can observe, number 1, that the exponential graph will always cut the y-axis at the point 0 and 1. Maybe you can tell me why. If you do so, send me the message. Why do you think will any exponential graph will cut the y-axis at the point 1? That is my one question to you. That is also one important characteristic about the exponential graph. Secondly, you need to know that the exponential graph is an increasing function. Right? I think you probably know what I'm talking to or referring to there. Right? The exponential graph is an increasing function. Thirdly, the domain. Now, if I mention domain, I'm referring to the x values. Now, looking at the graph there, we can see that continues until to infinity to the left, and if you go up, it will continue to the right until infinity. What that tells us is that x is an element of all real numbers. What it basically means, learners, is that the domain or the x values of the exponential graph will be all possible values. So we will write it in the form x is an element of all real numbers. Then if we refer to secondly about the range, another word for range will be your y values. Your range, we can write it into two forms. In actual fact, we can write it into three forms. Looking at the graph once again, the range referred to the y values. Now looking at that, we can see that it's from the y-axis upwards. So what that means, we can write the range as y is greater than 0. Another form of writing it is y is an element between 0 and infinity. Right? Looking at, just to explain to you again, this from here upwards is what we call the range, and that is why it is always greater than 0. And then lastly, what you need to know about the exponential graph is that the y-axis is your asymptote. Right? Any exponential graph means the y equals to 0 is your asymptote. So these are just 5 basic characteristics that you need to know. You need to understand it before you can continue doing the inverse graphs. So make sure, learners, that you need to know all these characteristics or functions so that as we go on, that things will make more sense to you. Okay, let's have a look at something we would like to do or that you need to know before we continue. And that is, it might be early in the year, you work with a chapter that they call with logs. If you didn't, don't worry, there's just one basic aspect I need to explain to you about when you work with exponential graphs, where the inverse graph is going to be the log graph. So what I'm referring to is what I have here on the page. Like I said, this is just revision. The definition of a log is that the log of a number is equal to the index, or it says the log of a number is equal to the exponent. Now what that means is that if we take a number of 20, like 25, that is the number. 25 we can write in another form as 5 squared. Remember, 5 squared means 5 times 5, and that gives you the 25. Now when you have something like 5 squared, we refer to 5 as the base, and we refer to the 2 as your exponent or your index. So you need to understand this terminology here when you have to write from exponential form into log form. As it says there, the definition of a log, the log of a number, you can see I'm referring to the number here, is equal to the index. Now if I have to write this 25, this number, into log form, then we're going to write, as the definition says, the log of the number. So the number there is 25, and then it says further is equal to the exponent of that number. Now to get the exponent of that number, you write it into the exponential form, and therefore the exponent in this case is equal to 2. So as the definition says, the log of a number which is 25 is equal to the exponent which is 2. And then 5 represents your base, and we will put or write the base there with log. Now reading this over here is what we say, the log of a number with base 5 is equal to 2. Right? Reading that again, it says the log of 25 with base 5 is equal to 2. Now learners, you need to understand this concept before we can move over going into the log graph.